I'm Ms Thomas, Curriculum Lead here for Science at Chepstow School. I hope you enjoy meeting the team and getting to know us a little bit better. We've put together a few demonstrations for you so you can see what goes on here in the department and some experiments that you might participate on in the future. Hopefully you enjoy it. See you soon!
Go. Okay, my name is Dr. Perkins. I'm one of the science teachers here. I specialise in A-level chemistry. I'm also the secondary in the department. I've got a series of experiments to show you based on different areas of chemistry and what students tend to study. The first one's to do with the electroplating industry. It's techniques by which we can coat surfaces, metal surfaces with other metals. Example I've got here is we've got a copper compound, we've got a zinc compound, we've got a copper electrode, we've got a zinc electrode. If you have a look at the dial here, there's no voltage going through, I've got no power supply whatsoever, but as soon as I put my electrode in, I get a current. And that's because the chemicals are working with and against each other at the same time in order to create a circuit where electricity can flow. And it's the chemicals that are dominating that. If we run out of a chemical, then the circuit breaks. Okay, and all we've got here is a piece of paper with a special chemical on it that allows current to flow. This is used in coatings science, where we might choose our electrode specifically to coat it with a particular metal. So that's my first example. Okay, my second demonstration will come into things like water testing, where we look at contaminants. One of those might be a sulfate-based salt that might have found its way into water, and we can do a simple chemical test with that by using barium chloride. Now, barium is particularly good in fact that when you link it to a sulfate, when it reacts with any kind of sulfate, you get a distinct precipitate. Like that. So straight away I've got barium chloride. As soon as I add it, we get a nice clear precipitate. That is going to be a barium sulfate, and that is our test for sulfates in themselves. So we've got 4 different sulfates here. We've got copper, zinc, we've got aluminium, we've got iron. All 4, because they are sulfates, give us a positive test with that particular reagent. Okay, so my second wet chemical test that linked with the one that I just showed now is to do with chlorides, bromides and iodides. Now chlorides are very common in water supplies as it is, bromides and iodides not so much, and sometimes it's important to be able to test for all three. So the way we do that is by using material that is used in photography, which is silver nitrate, and with any chloride you get a white precipitate, with a bromide you get a cream one, and with an iodide you get a yellow one. Okay, so we can straight away distinguish between, and at GCSE, students know this particular reaction. At A level, the expectation is a bit more detailed. Sometimes the chloride and the bromide can be a little bit difficult to tell. So the way to do it is, if you take dilute ammonia, which you can find in hair bleach, and you add that, what you should find is the precipitate starts to disappear. If I give that a shake now, there's a lot less precipitate in there now, so I know it's a chloride. If I do it to the bromide, it will not work. So give that one a little shake. It hasn't changed in any way, shape or form. The iodide would be the same. So if I had 4 lots of this again, and there it is, give it a bit of a shake, there's no change. However, if I change to concentrated ammonia, the bromide will disappear. As you can see, the precipitate has gotten less. So if I give this a little bit of a stir around, you can see it's disappeared. The iodide on this one will not work. Okay, so you can see that the precipitate is not disappearing. And that's my second one. There you go. Okay, and for my next trick is an area of organic chemistry, my personal specialism as a former drug chemist. The reaction I'm going to quickly show you here is found in breathalyzers, particularly at Christmas, ladies and gentlemen. So they use crystals of this chemical here called potassium dichromate. And when you blow your breath in it, those crystals turn green, and it's the colour change that the breathalyzer detects. In synthesis, it's very good at turning what we call alcohols into carboxylic acid. So the example I've got here is ethanol, which we all like to have a little drink at Christmas. Merry Christmas, one and all. If you oxidise it, which is what this material will do, you get what we call a carboxylic acid. So this is where your vinegar comes from at home. Okay, so when I add this to the top, as soon as it hits the solution, it should turn green to show that oxidation is currently going on. So as you can see, as soon as the dichromate hits, it's turning green. That tells me that I've got the oxidation going on. And that's my 3 demonstrations, ladies and gentlemen. I hope you have a fantastic Christmas and New Year. Take care of each other.
I took both chemistry and biology at A-level, partially because I need both of them to take medicine, which is what I want to do, and also because I really, really enjoy the subjects, and I've really enjoyed them at GCSE. So since starting the courses, we've almost finished year 1 for both of them, and so far I'm absolutely loving it. All of the teachers are really, really helpful and make sure that you understand everything, and with everything that's going on with COVID, I think that level of security has been really, really helpful, not just me, but kind of the whole class, because we know that whatever happens, we're getting the grades that we deserve. And I'm really enjoying the actual course. It's very interesting, and it's definitely slightly harder than a GCSE, but I think it's much more interesting. But yeah.